All right, ladies and gentlemen, welcome. This is the beginning of Chapter 5, where we're going to be talking about polynomials and polynomial equations. So our first lesson here is a review of using the properties of exponents. Basically, by the end of this lesson, you're going to be able to do multiplication, powers, and division for exponents. And you'll also be able to simplify a negative and a zero exponent. So let's go ahead and look at the list of our properties. Now that's a pretty long list over there. Most of these, like I said, should be review. We're going to write a formal definition for them, but ultimately we'll do some examples. Okay. So let's just start and go through the list here. Product of powers is when you have two numbers of the same base and you are multiplying them together. So notice there's multiplication going between the two terms here. And this is a to the m power and this is a to the n power. And basically what this definition, what this property does is says that when we're multiplying these two things together, the exponents can be added together. So for example, 2 to the 4th power times 2 to the 7th power would be 2 to the 4 plus 7, or 2 to the 11th, right? It also is with variables. If you had like x squared times x to the 4th, that would be x to the 6th, because you're simply adding the exponents together. Okay, so multiplication, product of powers, is I add the exponents together. Okay, power of a power is when we have a term in parentheses being taken to another power, and when this happens, we multiply the exponents together. So again, as an example, 2 to the 4th to the 7th power. Notice how the 2 to the 4th is in parentheses and the 7 is on the outside of those parentheses. This would be 2 to the 28th power, because that's what 4 times 7 would be. Again, with variables, if we had y to the 3rd to the 4th power, that would be y to the 3 times 4, or y to the 12th, because I'm multiplying the 3 and the 4, right? Power of a power, I multiply these together. We've got power of a product, and what that tells us is that if I have two different numbers inside the parentheses like that being multiplied together, this is the same thing as taking that power to both of them. So if this was like 2 times 3 squared, this would really be 2 squared times 3 squared. It's the same thing. Or with variables, if I had n squared m cubed, this would be n squared, I should square that, n squared squared times m cubed squared. I ran out of space. But I'm taking the n squared squared and n cubed squared. Whatever was in the parentheses is being squared, as long as it's being multiplied. The negative exponent property says that when I have a negative exponent, a to the negative n, that this is the same thing as 1 over a to the positive n. So notice how I took a reciprocal. Okay, a negative exponent shows a reciprocal. So if I had 2 to the negative 3 power, that's really the same thing as 1 over 2 cubed, because I took the reciprocal. And notice that I made the negative exponent positive when I put it in the denominator. So that's 1/8. Okay. Same thing with variables. A to the negative 4 is really 1 over a to the 4th. I just flip it. I take the reciprocal. Negative exponents are reciprocals. The zero exponent, a to the 0th power, is 1. If we take anything to the 0th power, it is always equal to 1. So negative 89 to the 0th power, well, that's equal to 1. Or if I had b to the 0th power, that is also equal to 1. In fact, we could go really crazy and say negative 2 pi to the 0th power, well, that's equal to 1, because anything to the 0th power is always equal to 1. All right, we're almost done here. Quotient of powers says when I divide variables, like variables, the exponents are subtracted, a to the m minus n. So if I had 3 to the 4th divided by 3, notice that's 3 to the 1th, right? This would be 3 cubed as my solution. Or if I had x to the 6th over x squared, that would be x to the 6 minus 2, which is x to the 4th. Notice I'm not dividing 6 and 2. I'm dividing the x's, which means I subtract the exponents. Finally, our last property, the power of a quotient. If I have a fraction here, a divided by b, and something being squared, or an exponent on the outside, we should call that m. This would be a to the m over b to the m. So all this says is if there's something in parentheses, that this exponent goes to both the numerator and the denominator. 2/3 to this being squared would be 2 squared over 3 squared, right? A squared over b cubed squared would be a squared squared over b cubed squared, which would go to a to the 4th, b to the 6th. Okay, whatever that exponent is outside the parentheses goes to both the numerator and the denominator. So that is a big list of our properties of exponents. Everything else we're going to do in this lesson is just going to be examples of how we do this. So let's do 2 examples, and then I'm going to have you guys do some on your own. So here's some examples with numbers. All right, we have -4 times 2 to the 5th squared. I want you to notice that this is very similar to our power of a product, a times b to the m. Notice that I've got something being multiplied here, something being multiplied here, parentheses, and then the exponent. So what I know that I can do, and there's many ways to do this, by the way. What I know that I can do, though, is take -4 squared times 2 to the 5th squared. Right? That's my power of a product property at work, saying, well, whatever is in the parentheses, I can take that power to both of those things, as long as this is multiplying. So simplifying this becomes 16 times, and then 2 to the 5th squared. I have a power to a power. That's 2 to the 10th. Now we could simplify this down to a single number if we really wanted to. The 2 to the 10th being something very large. It turns out that when you actually do this whole thing, it ends up being 16,384. Okay, but important thing about this example is seeing the properties in action. Okay, I've got power of a product here. The squared goes to both of these, and then I've got power to a power here, and then I'm multiplying things together. Okay. What about this one here, part B? Well, I've got a negative exponent outside of this thing with a fraction. So notice that this is my quotient rule, right? Where whatever's on the outside of the parentheses can be taken to both of these. So what I really have here is 11 to the 5th to the -1 power over 11 to the 8th to the -1 power. And now you'll notice the same property that was in the previous one, power to a power. So this is really 11 to the -5th and 11 to the -8th. But now we have negative exponents. So we can do one of two things here. We can deal with the negative exponent, or we can use our quotient rule. Remember quotient rule saying that if I'm dividing things of the same base, then I can subtract the exponents. So let's do that. This is 11 to the -5 minus -8. Right? I'm subtracting these. -5 minus -8, and that's going to be a +3. And so 11 to the +3 is 1,331. So again, we got a final numerical answer here, but using the properties is the important part. I did my quotient property, that -1 goes to both the numerator and the denominator. Then I did my power to a power property, and I multiplied those exponents. And then finally, I did the quotient property where I subtracted the exponents. You also might be asking, what if we did this in a different order, right? Well, you actually can do this in a different order. If we wanted to do the quotient rule first and do 11 to the 5 minus 8 and get 11 to the -3 to the -1, we could then do the power of power and make this to 11/3 that way. So you have some flexibility in the order that you do them. It's not all just like this static way to do it. Just remember your properties, and you'll make it through okay. All right, I got a problems for you on your Canvas to check out. Give those a try, and then in the next video, you can see the worked out solutions to see if you're doing it correct. All right, so we'll see you in a minute.